Picture two photons entangled across the cosmos. One is here on Earth, the other is millions of light years away, perhaps near a distant quasar. They are connected by a bond so strange that Albert Einstein called it spooky action at a distance. Yet, according to one of the most radical proposals in modern physics, that bond is not just a metaphysical link, it is a physical bridge, a wormhole. In 2013, the physicists Juan Maldacena and Leonard Susskind proposed a mind-bending idea known as the ER equals EPR conjecture. They argued that quantum entanglement, the weird connection that Einstein famously despised, is actually equivalent to a microscopic Einstein-Rosen bridge, a wormhole threading through the fabric of space-time. If they are right, then the universe is filled with an invisible network of tiny tunnels connecting every entangled particle across the cosmos. For years, this was purely theoretical speculation, a beautiful piece of mathematics with no experimental anchor. This month, in June of 2026, a team of physicists from Portugal and Japan published a paper that changes everything. They have found a way to test the ER equals EPR conjecture using ordinary entangled photons. The implications are staggering, reaching into the very heart of quantum gravity and the nature of reality itself. I want you to imagine two particles that are entangled. You measure the spin of one, and instantly, the other particle's spin is determined, regardless of the distance separating them. This happens faster than light, in zero time, across any distance. Einstein, Podolsky, and Rosen used this thought experiment in 1935 to argue that quantum mechanics was incomplete. They believed there must be hidden variables, local instructions carried by the particles that we simply hadn't discovered yet. They were wrong. Decades of experiments have proven that entanglement is real. The correlation is instantaneous and non-local. It seems to defy the very structure of spacetime, but what if it doesn't? What if the reason entanglement appears to violate locality is because the particles are actually connected by a physical shortcut through spacetime? That is the essence of the ER equals EPR conjecture. ER stands for Einstein-Rosen bridge, the mathematical description of a wormhole. EPR stands for Einstein-Podolsky-Rosen, the famous paradox that introduced the concept of entanglement. ER equals EPR means that wormholes and entanglement are the same thing, described by the same underlying geometry. The new paper, published on the Arkwharf on June 1, 2026, titled Testing the ER equals EPR Conjecture with Entangled Photons, takes this abstract idea and makes it concrete. The authors, Kemet Jusufi and his collaborators, started with a classic problem in general relativity, the gravitational field of a massless particle traveling at the speed of light. This is described by the Eichelberg-Sexel shockwave metric, a mathematical solution that represents a burst of energy moving at the speed of light. In its standard form, this metric contains a singularity, a point where the curvature becomes infinite. But the team introduced a subtle modification. They smeared the point-like source over a tiny length scale known as the string-inspired length scale, which effectively rounds off the singularity and makes the geometry perfectly regular. What they discovered next is the stuff of physics legend. By performing a coordinate transformation, they revealed that the transverse geometry of this smeared shockwave is actually a zero-throat Einstein-Rosen wormhole. In plain English, they found that the gravitational field of a photon, when regularized using ideas from string theory, naturally forms a wormhole geometry. The photon is not just a particle, it is a doorway. This is the first explicit geometric realization of the ER equals EPR conjecture for entangled photons. The math itself is telling us that the photon's gravitational footprint is a bridge. Let me pause and bring Richard Feynman into this conversation because he would have found this absolutely delightful. Feynman was a master of path integrals, the technique that sums over all possible histories of a particle to calculate its quantum behavior. In Feynman's view, a photon traveling from point A to point B doesn't just take one path, it takes every possible path simultaneously, and the paths interfere with each other to produce the final result. Now imagine that those paths are not just abstract mathematical constructs. Imagine that they are actual geometrical structures, wormholes that connect every point in space-time. The ER equals EPR conjecture in this context suggests that the entanglement between two photons is precisely the sum over all the wormhole connections between them. Feynman would have loved the audacity of the idea. He once said, "I think I can safely say that nobody understands quantum mechanics." But he also believed that we should keep pushing, keep finding new ways to visualize the invisible. The ER equals EPR conjecture is exactly that, a new way to visualize entanglement as geometry. But how do you test a conjecture about wormholes and entanglement using photons? The key is the gravitational self-energy of the photon. Even though a photon has no rest mass, it does have energy, and energy curves spacetime according to Einstein's equations. The team calculated this gravitational self-energy for a pair of entangled photons. They found that when the photons are coincident, created back-to-back in a process like electron-positron annihilation, the wormhole carries no additional binding energy. It is a flat bridge. But as the entangled photons separate, moving apart to a distance d, the ER bridge stretches, and a logarithmic interaction energy emerges. This energy is incredibly tiny, suppressed by a factor of 1 over the photon's wavelength, making it virtually undetectable under normal circumstances. For optical photons, the corresponding collapse time, the time it would take for this gravitational interaction to affect the quantum state, exceeds 10 to the 30 years. That is a number so large it loses all human meaning. 10 billion trillion years. The photons are effectively immune to gravity-induced wave function collapse. But here is the crucial insight. Even though the effect is tiny, it is well-defined and calculable. The team has provided a precise mathematical formula for this energy, a formula that can, in principle, be tested using ultra-sensitive interferometry, or by observing the behavior of entangled photons in extreme gravitational fields, such as those near a black hole. This work establishes a rigorous playground for testing ER equals EPR. It is no longer just a philosophical speculation, it is a physical model with specific, testable predictions. One of the most exciting implications is the entanglement entropy interpretation. The authors computed the entanglement entropy of null intervals in the shockwave geometry. By introducing an effective entanglement temperature, they recovered the exact same scaling and normalization for the gravitational self-energy. This is a profound result. It shows that the thermodynamics of entanglement, the information theory of quantum connections, has a direct geometric counterpart in the warping of space-time. The entropy of entanglement is the area of the wormhole throat. The temperature is the curvature. This is the holographic principle in action, the idea that the physics of a volume of space can be encoded on its boundary. The ER equals EPR conjecture is the holographic principle applied to individual particles. Now let me take you on a journey through the physics of this discovery, because it touches on some of the deepest questions we can ask. What is the nature of space? Is it smooth and continuous, as Einstein believed, or is it granular and discrete, as quantum mechanics suggests? The ER equals EPR conjecture points toward a third possibility, that space is emergent. It arises from the entanglement structure of the quantum state. If two particles are entangled, they are connected by a wormhole. If they are not entangled, the wormhole is absent. The geometry of spacetime is literally woven from the threads of quantum information. This is a radical departure from the way we usually think about the universe. We tend to think of space as a stage and particles as actors moving across it. ER equals EPR suggests that the stage and the actors are the same thing. The stage is made of the relationships between the actors. This idea has profound implications for black holes. You might remember Stephen Hawking's famous bet that information is lost when it falls into a black hole. The ER equals EPR conjecture offers a resolution. When a particle falls into a black hole, it becomes entangled with the radiation that the black hole emits. This entanglement is a wormhole connecting the interior of the black hole to the outside. The information is not lost. It is encoded in the entanglement, in the geometry of the wormhole. The black hole is not a destroyer of information. It is a transformer. It changes the form of the information from local particles to non-local connections. This is the leading idea in black hole physics today, and the new photon model provides a way to test it in a controlled laboratory setting. Let me also mention the Leggett-Garg inequality, a temporal version of Bell's inequality that tests the non-classicality of a system over time. Another paper, published on June 11, 2026, investigated the violation of this inequality in the context of photon-graviton conversion. When a photon propagates through a magnetic field, it can convert into a graviton, the hypothetical quantum particle of gravity. This process creates a superposition of photon and graviton states. The researchers showed that the temporal correlations of this system system violate the Leggett-Garg inequality, providing a novel way to probe the quantum nature of gravity. This is complementary to the ER equals EPR work. While the ER equals EPR paper focuses on the geometry of entanglement, the Leggett-Garg paper focuses on the dynamics of quantum gravity. Together, they are building a toolkit for testing the quantum nature of the gravitational field. And this is where the story gets even more exciting. The ER equals EPR conjecture is not an isolated idea. It is part of a larger framework known as the holographic principle, which emerged from the study of black holes and string theory. The holographic principle says that the universe is a hologram. The three-dimensional world we experience is a projection of information encoded on a two-dimensional surface at the boundary of the universe. The ER equals EPR conjecture extends this idea to individual particles. Every entangled pair is a tiny hologram, a two-dimensional surface encoding a three-dimensional connection. The new photon model provides a concrete example of this holographic encoding. The entanglement entropy of the photons is exactly the area of the wormhole throat, scaled by the Planck length. This is the holographic principle, not as a theoretical abstraction, but as a calculable feature of a real physical system. As we stand here in June of 2026, we are witnessing the birth of a new kind of physics. It is a physics that treats information and geometry as two sides of the same coin. It is a physics that sees the universe as a network of connections, a spider web of entanglement stretching across the void. The ER equals EPR conjecture is the map of that web, and the new photon model is the first compass that can read that map. Of course, we are a long way from confirming the conjecture. The effects are tiny and the experiments are daunting, but the theoretical foundation is now solid. We know what to look for. We know how to calculate the signal. We have a path forward. I want to leave you with the image of two photons created together in a burst of energy, flying apart at the speed of light. According to the new model, they are connected by a microscopic wormhole, a bridge in the fabric of space-time. That bridge is invisible to us, but it is real. It carries the information of their entanglement. It encodes the geometry of their connection. And one day, perhaps soon, we will be able to detect it, to see the wormhole for the first time. That will be the moment when we finally understand that space is not empty. It is filled with bridges connecting everything to everything else. This is the Feynman way. We do not accept the universe as it appears. We dig deeper. We ask, what is the machinery behind the curtain? And sometimes we find that the curtain is not a curtain at all. It is a doorway. Keep questioning, keep exploring, and remember, the most beautiful thing we can experience is the mysterious. It is the source of all true art and all true science. This is physics made simple. We will see you next time when we dive into the quantum mechanics of time and ask whether the future is already written or if we are making it up as we go along. Until then, stay curious.